Hi, this is Julie, and in this video I'm going to discuss how we can repeat code in C++ programming using while loops. So I'm first going to talk about why do we use loops, then a few basics about loops, and then more specifically how we can use the while loop in C++ programming. So let's start just talking about why do we even use loops. A lot of times we may have a program that may need to do the same thing multiple times. So for example, what if I wanted to print hello 5 times? I could write the first statement to print hello, and then I could just copy that and paste it 4 more times so that I have 5 C++ statements that all say cout hello. And that will work just fine. When I run this program, I'll have hello displayed on my console window 5 times. And so this is a situation where I'm not using a loop, but I could make this code better if I did use a loop. And in fact, this really isn't a very good solution for a number of reasons. Now, copying the code and pasting it 5 times works, and I will get the correct output. But it's really not a very scalable solution. For example, what if I wanted to print hello 100 times? Then I'd have to copy and paste it 100 times, or I guess paste it 99 times, or 500 times, or however many times I want that code to be executed. And if I'm pasting it a whole lot of times, I might even lose track of how many times I pasted it, so I might not even get it pasted the right number of times. Now that would work, but now what if I want to change how it's displayed or how it prints? Let's say I want to add an exclamation point after the word hello. If I have 5 of them, I have to make sure that I edit all 5 of the print or cout statements, which I could probably do that and I probably wouldn't make a mistake, but I might miss one of them. If I have hello 100 times, I'm much more likely to make a mistake if I had to go in and modify all 100 of them, and so forth and so on. The more I have of them, the less likely it is that I'm going to modify them all exactly the same. And sometimes what we're trying to modify isn't something just as simple as printing hello. It could be several lines of code that I want to repeat over and over. And then it becomes much more challenging to modify it consistently. Also, I could have some situations where when I write the program, I don't know how many times I'm going to want to print the word hello. For example, I might ask the user how many times they want to do something, and then based on their input, my program will display it that number of times. And I can have a variety of situations where, based on some condition, I'm going to want to do something, and I don't know what that condition will look like until the program actually executes. So when I don't know how many times I want to execute it, I can't copy and paste and print it in my program that many times. So this is where loops come in and why loops are going to make our lives a lot simpler. So let's talk about some benefits of loops. And there's this idea of something called modular programming, where we want to write our programs in a way where we only write code once, we don't have repeated code, and we want to organize it in a way that's easy for us to understand and modify. And loops are really helpful with this. So if I'm using modular programming and I use a loop, I only have the code in my program once, and if I need to modify it later, I only have to go to one place to make the modifications. It could be that I have an error in the code that I wrote, or just that I want to change it for some other reason. And usually code doesn't stay static. Usually we do end up modifying it over time, so we want to write our programs in a way that makes it easy for someone else to modify. Also, when we only have our code written once in a program, and we're using things like loops, and other modular programming structures, usually our program is going to be easier to understand and simpler to write. And then, as we just said a moment ago, sometimes we don't know in advance how many times we want some code to execute. And this is where loops will help us, because the loops can use any number of different conditions to decide if they should execute the code again. And that's what we're going to look at now. So, when I have a loop, how does it work? Well, first of all, let's just define the word loop. And that's a structure that's going to repeat statements as long as the condition is true. So we're going to have some type of condition that we're going to test, and that's going to determine if our loop should execute. And this is going to look a lot like our if statements look, where we have a test condition in parentheses, and if that test expression evaluates to true, then we're going to execute the code inside the if statement. The loop's going to work very similarly, except the loop can do it multiple times. Now, if our test expression is true and we do want to execute the loop, then we're going to execute the statements that are inside the loop body. These are the statements that we want to repeat, and it's going to look a lot like the body of an if statement, where we can use the curly braces to set aside statements as a code block, and that will be the body of what we execute, whether it's an if statement or a loop. And there's another term I want to mention called iteration, and that just means each time we repeat that loop body or execute a repetition. Each repetition is going to be called an iteration. So in the case of where I'm printing something 5 times, I'm going to iterate that code 5 times. So let's look at what it looks like to write a program that's going to print hello 5 times using a loop. And first I'm going to show you the flowchart here. I'm going to begin by creating a special variable called a control variable. I'm going to name it count. And this variable is going to be used to determine if I want to execute my loop again. So before I ever execute the loop or look at it, I'm going to initialize count to a value of 1. Now I'm going to begin the loop by testing the value of count, or comparing its value to 5. So in this case, my test expression is count less than or equal to 5. If count is less than or equal to 5, and that test expression is true, then I'm going to execute the loop body, and those are the 2 processes on the right. If this decision, count less than or equal to 5, is true, then I'm going to execute the process that says print hello, and I'm going to execute a second process here in this example that's going to update my control variable. I'm using count to see if I want to execute the loop, and so every time I execute this loop, I'm going to add 1 to the value of count. Now after I add 1 to count, I'm going to go back up to the part in the program or in the flowchart where I'm going to look at the test expression again. So after I've executed this loop 1 time, count now has a value of 2. I'm going to go back to test expression, and I'm going to compare count to 5 again. This time count is 2. 2 is less than or equal to 5, and so I'll execute the loop body again. Inside the loop body, I'll add 1 to count and give it a value of 3. I come back to the test expression, and I'm going to do this over and over until count has a value of 6. And after I've executed this loop body 5 times, count's value is 6. I'm going to compare count to 5. It's no longer less than or equal to 5. So this test expression will be false, and I will move on to the next line of code. So this is how I can print hello 5 times using a loop in a flowchart. I have a diamond for my test expression because this is where I'm going to decide whether or not to execute the loop. So how do we translate this flowchart into C++ code? So solving the same problem here, I want to print hello 5 times. I'm going to begin by initializing my control variable. That was the first process in the flowchart where I had a variable count and I initialized it to 1. Then I'm going to look at my test expression. This looks a lot like the if statement that I use for branching, except it's a while loop, and I'm going to use the keyword while in place of the if. So I'm going to say while, and then in parentheses I'm going to put a test expression of count less than or equal to 5. Count less than or equal to 5 is either going to have a value of true or false. And if it does have a value of true, then I'm going to execute all of the statements inside of the code block with the curly braces. And with the loop, that's what I'm going to call my loop body. So these two statements here that are inside the curly braces or belong to this code block are both a part of my loop body, and I will execute them if that test condition was true. So just like we had over in the flowchart, I have the same things here, but the way it's organized is the line where I'm saying while count less than or equal to 5, that was my decision diamond in the flowchart. The two statements inside the code block were the two processes that I executed if the decision had a value of true. So if my count is less than or equal to 5, I'm going to display hello, and I am also going to update that control variable of count by incrementing it by 1 or adding 1 to count's value. After I get to the end of that code block, I'm going to go back up to where the while statement is, and I'm going to look at that test expression again. The test expression count less than or equal to 5. If that is still true, then I will execute the loop body again. So looking at this as a numbered list of items, I'm going to do number 1, initialize control variable, only 1 time. Then I'm going to do the test expression. If it's true, I'll execute the loop body and update the control variable. And then I'm going to go all the way back up to 2. And I'm going to do statements 2, 3, and 4 multiple times as long as that test expression is true. After I've executed this loop body 5 times, in this example, my count will have a value of 6. The test expression will no longer be true. And now I will continue by executing the next line of code, which here is a statement that says goodbye. So for this little code snippet, I'm going to execute count equal 1 a single time, but I'm going to execute the while statement with the while test expression and the loop body several times. Once that loop is finished, then I'll continue by executing goodbye a single time. Now there's one other situation I want to talk about here, and that's something called infinite loops. And usually when you create an infinite loop, this is something that you did by mistake and you weren't intending to do. And this is a loop that's going to repeat forever. And the reason it's going to repeat forever is that the test expression will never become false. And there are several reasons that can happen. A common reason would be that my control variable is never updated, and so the test expression can never become false. So let's see what that would look like in this code example. And this is the same exact code we've been looking at here. I'm initializing my control variable to 1. I have a test expression that compares count to 5. And I have a loop body that prints hello if the test expression is true. But the difference here is that I don't have the line of code that ever modifies count. And so count will always have a value of 1. Count's value never gets modified. And so I'm going to go back up to my test expression. I'm going to compare count to 5. Count is still 1. I'll print the loop body again, or execute the loop body again, and go back up to the test expression. And what I'll see if I execute this program is my screen will fill with lines of code that say hello, 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 over and over until I actually kill that process. This program will never print the line that says goodbye. We will never get to that line in the code because we have an infinite loop. And the loop body is just going to continue to execute over and over because the test expression is always true. And this is one reason why we want to test our code. Most likely we didn't intend for this code to work this way. And when we go to test it and see that this is happening, we know that we've left something out here. We need to modify our code so that count can eventually become greater than 5. Our while loop will then stop executing and our program will continue with the line that says goodbye.